Assalamualaikum. We are from Group 10 and we will explain about the technique of differentiation. So I will introduce myself and my teammate. My name is Nurul Ani Batisha binti Azlan and I will explain question number 1 and 4.
And my name is Kaya Zafir binti Asri Izri and I will explain question 3 and also conclusion.
Hi, my name is Nur Anis Afrina binti Awaluddin and I will explain question 2.
Differentiation is a fundamental concept in calculus that focuses on finding the derivative of a function. In simple terms, differentiation measures how fast a quantity changes. The result obtained after differentiation of a function is called the derivative. The derivative is commonly represented by symbols such as dy per ds or f prime x. Next, there are three primary ways derivative can be interpreted in calculus. First, the instantaneous rate of change. This refers to how a function changes at a specific point at time, rather than over a whole interval. If we are measuring motion, the derivative of a position function gives the instantaneous velocity. Next, the mathematical notation of derivative. If we have a function written as y equal to fx, the derivative can be represented as dy per ds of f prime x. Next, the slope of the tangent line. At any point on a curve, the derivative tells us the slope of the tangent line touching the curve. A positive slope means the function is increasing, while a negative slope means it is decreasing. Next, I will explain the technique differentiation in calculus. First is the power rule. This rule is used to differentiate power of x. Instead, the exponent is multiplied by the coefficient, and the exponent is reduced by 1. The second technique is the constant rule. This rule states that the derivative of any constant number is always 0 because constant values do not change. Next, the product rule. This is used when two functions are multiplied together. We differentiate the first function and multiply by the second. Then add the first function multiplied by the derivative of the second. Next, we have the quotient rule. This rule is used when one function is divided by another function. This technique is important because it helps us solve different kinds of problems involving rate of change and function. Next, the chain rule. It used for composite function, which means a function insert another function. This technique requires us to differentiate the outer function first, followed by the inner function. Next, implicit differentiation. It is used when y cannot be easily separated from the equation. We differentiate both sides of the equation with respect to x. When differentiating terms involving y, we must multiply by dy per dx using the chain rule. Last, trigonometric rule. It is used for differentiating trigonometric functions such as sine, cosine, tangent, and logarithmic and exponential function.
For question number 2, we have two questions in A, which is 2a and 2b. For 2a, the question is y equal to ln x squared plus 1 cos x plus 1. So we're gonna use product rule. Product rule is what? Product rule is dy over dx equal to uv prime plus vu prime. We're gonna divide the equation into two, to u and v. For the u, we're just gonna take it ln x squared plus 1, and for the u prime, we're gonna differentiate it. It becomes 2x over x squared plus 1. For the v, we're gonna take cos x plus 1. V prime, we're gonna differentiate it and become negative sine x plus 1. So we're gonna put all the thing we have in the equation, which is uv prime plus vu prime. So we're gonna get ln x squared plus 1 sine x plus 1 plus 2x cos x plus 1 over x squared plus 1. So I put it in very nice form, which is 2x cos x plus 1 over x squared plus 1 minus ln x squared plus 1 sin x plus 1. Next, for the 2b, our equation is y equal to tangent 4x over 1 plus x squared. Same with the 2a, we're going to use u and v, but this equation, we're going to use quotient rule. Quotient rules is dy dx equal to v du dx minus u dv dx over v squared. So for the u, we got tangent 4x, du dx, we got 4 secant squared for x. V, we get 1 plus x squared, and dv dx, we got 2x. So we're going to put all the information in our equation, which is v du dx minus u dv dx over v squared. So I'm going to put all the information in this equation. Next, we have to expand the equation. So when we expand, we get 4 secant squared for x brackets 1 plus x squared minus 2x tangent 4x and 1 plus x squared. square. And then we're gonna put it in a very nice form, which is 4 1 plus x squared secant square 4x minus 2x tangent 4x over 1 plus x square square. That's it.
Now I will explain the question 3. We are given the implicit equation ln of y plus cos of x squared plus e to the power of y equals to 2xy squared. Our task is to find dy over dx. The main technique we must use here is implicit differentiation. This is because the variable x and y are mixed together. The core rule of implicit differentiation is that every time we differentiate a term containing y with respect to x, we must multiply it by dy over dx by using the chain rule. To make this easy to follow, let's differentiate the equation term by term from left to right. Let's look at the first term, ln y. Here we apply the chain rule for logarithmic functions. The derivative of ln y with respect to y is 1 over 1. Since we are differentiating with respect to x, we multiply it by dy over dx. So the derivative for this first term is 1 over y dy over dx. For the second term is cos x squared plus e power of y. For this term, we must use the chain rule because it is a composite function inside a function. First, we differentiate the outside trigonometric function. So give us negative sign x squared plus e power of y. Second, we multiply this by the derivative of the inside angle, which is x squared plus e power of y. The derivative of x squared is 2x by using the power rule. The derivative of e power of y remains e power of y, but since it contains y, we attach dy over dx, giving us e power of y dy over dx. When we combine them together and expand the bracket, we get negative 2x sine x power of 2 plus e power of y minus e power of y sine x power of 2 plus e power of y dy over dx. And then the equation 2xy squared, this is a multiplication of two distinct terms, 2x and y squared. Therefore, we cannot differentiate them separately. We must use the product rule, which is ub prime plus bu prime. Let's set our u as 2x, so u prime is 2. And let's set our v as y squared, so v prime is 2y divided over dx. Applying the product rule formula, we get 2x times 2y divided dx plus y squared times 2. Simplifying this given 4xy dy over dx plus 2y squared. Now that we have differentiated every term, let's put them all back into our main equation. Let's show like at the video. Our next step is purely algebra. We need to isolate dy over dx. To do this, we move all terms containing dy over dx to the left hand side and all other terms to the right hand side. Let's show at a video. And then we factor out dy over dx on the left side. Then dividing both sides, we get our derivative expression.
For question 4, we let fx equal to x squared minus 1 over cube root x. Then we simplify x squared minus x power of minus 1 over 3. Then we need to find derivative. So we use the power rule from fx. We substitute to x minus 1 over 3x power of minus 4 over 3. We simplify it into 2x plus 1 over 3x power of 4 over 3. Then we have target point, which is x equal to 8.02 and x naught is 8 since it is closer to number of x. Then we got 0.02. We apply the linear approximation formula, which is fx naught plus x minus x naught equal to fx naught plus f prime x naught as equal to x naught. Then we substitute x naught, which is 8. Then we got 64.14111 since it 4 decimal place.
However, translating this theory into solving exam problems comes with its own set of challenges. Based on the question we just solved, we identified three core difficulties. First, in question 2, the challenge is rule recognition. It is very easy for students to accidentally mix up the product rule and the Gaussian rule, or completely forget to apply the chain rule to linear functions. Second, in question 3, we deal with algebra complexity. Since we are using implicit differentiation, dy over dx is scattered on both sides of the equation. This requires intense concentration because a single careless mistake with a negative sign during subtraction or factoring will ruin the entire final answer. Lastly, in question 4, the difficulty is about strategic approximations. To make the linear approximation work smoothly, we must be smart enough to choose the perfect reference point, which is a equal to 8, If we don't handle fraction and exponent like 8 power of 4 over 3, becomes extremely messy, especially when we are doing it without a calculator.